Okay, so this is chemistry, 6th period, 9/11/14, and we're going to talk a little bit about science and what science isn't. Does anybody here read Science Daily? It's a website. I would be surprised if any of you did. I use it throughout the year occasionally. They take scientific journal articles published by scientists, very often at universities or research institutions, and they do really nice one-page summaries that are at probably a little bit higher than the general public science level, but they're at a good science level for high school science students and people with some science background. And there was one today that I thought was especially interesting. So if I give you, you know what it means to crystallize? If I give you liquid water, room temperature, and we drop its temperature down to 10 below Celsius, what's going to happen to the water? It becomes ice. It becomes a solid. We can also call that crystallization. So it crystallizes. It goes into a solid phase. Its molecules become locked in place and they can no longer move freely. Science Daily this morning, I always pull it up and read it in the morning to scan the headlines for something of interest, and this is why. I forget where it was. They have crystallized light. Huh? How can you crystallize something that's not a form of matter? Okay. Well, we'll come back to that. Does that sound weird to you? It's really cool, isn't it? We'll talk a little bit about why it works. Sounds strange? Sounds crazy? Good. Good. So, it's emerging science. Okay, so we'll come back to the freezing light, the crystallizing light. For right now, let's say that there's a lot of stuff floating around out there that is science and that isn't science and that purports to be science. And there's this little acronym CONPIT. It's not the be-all, end-all, but it's a nice way to think about what is science. So we've got on one side that crystallizing light as an example, which you're all thinking is really bizarre and not possible, and it's light. It's not matter. You can't crystallize something that's not matter. Well, let's talk about something else. So when I was in college, I worked at a health food store all through college, a little natural food store, co-op in Youngstown. And we tended to be more the just natural food. So we carried, whole grains and beans and organic produce and soy milk when you couldn't buy soy milk in the regular grocery store. Not a whole lot of vitamins, some bulk herbs and spices and stuff. And there was another health food store in Youngstown that was more I will call it the health fad of the moment kind of place. So whatever, you were hearing about in those circles, that was like the next thing they had. We usually didn't. And there was a period when the big thing was oxygen water. So it sold for about $12 a gallon, or you could buy the little 8-ounce bottles for probably $3 or $4. Pretty expensive water, and it would reverse the aging process, grow your hair back. Clear up your acne, increase your intelligence scores, and probably mow your lawn. It was fantastic, and there were these brochures, this nice literature that went with it, and I got a hold of some and read them, and they talked about why this would change your life. Is $12 a gallon too much to ask for something that is going to change your life? Of course not. What would you pay for something that will change? Okay. Now, was there additional oxygen in that water? Yes. Can you introduce additional oxygen to water? Not bonded chemically, mind you, because that would be hydrogen peroxide, and you can drink it, but it'll make you throw up. You can add additional oxygen to water, yes. Is oxygen critical for cellular functions involved in skin, cellular repair, wound healing, all of those things? Yeah, absolutely. These are all scientific facts. Can you take a bunch of scientific facts? Now, the next question I have for you is, was the extra oxygen that was in that water available to any of your cells to do anything with? No. It was a bunch of malarkey. Somebody took an aquarium bubbler and an oxygen tank and bubbled, you can carbonate a beverage by running carbon dioxide through it under pressure. You can oxygenate a beverage by running oxygen through it under pressure. All you need is an aquarium soda and a pressure tank. And you can make your own oxygen water. And, if you find enough people who have a tenuous grasp on reality, you can sell it to them for $12 a gallon. This is how you can finance your college education if you don't get a scholarship. So, it was absolutely bogus. It was, it was the worst kind of just nonsense. Were there scientific facts in that brochure? Yes. You can take valid, fundamental scientific facts and truth and make inferences from them which are completely incorrect. That's what we call pseudoscience. Now, freezing light, crystallizing light, sounds like it could be pseudoscience. It's not actually. If we dig a little bit deeper, it's very valid. That's cutting edge science. Often the two sound similarly weird. So we have to be careful and look at these things through some kind of lens that tells us a little bit more about how to distinguish them. And Conpit is handy for this. Okay, so first of all, if we're looking at something and we're saying this is a scientific explanation, it has to be reasonably consistent with how everything else we know scientifically works. The wonderful thing about science is that the rules work in the same way every place, every time, for everyone. So gravity works equally well here above the surface of the Earth, feet above the surface of the Earth, as it does out in space between two little tiny specks of dust, as it does between the Earth and the Moon or the Earth and the Sun. The rules apply the same place every time, everywhere. And if somebody comes up with something and says, this is, groundbreaking science, but it's completely inconsistent with how everything else that we know works, you should probably be asking more questions. It's probably not scientific. It has to be observable. So we talked about the tea kettle. Coming into the room, the tea kettle's whistling, and you can explain it by saying water molecules are moving faster, they're moving through the opening, it's making the opening vibrate, therefore it whistles. Valid explanation. Or you can say, my friend Jane was in the kitchen 15 minutes ago, she turned on the tea kettle, she left. Unless you observed her doing that, that's not a scientific explanation. Unless you have a game camera in the kitchen and it takes a picture every time somebody walks near the stove. You can't do that. It has to be observable. It has to be observable. We can't observe who or what turned on the burner. We don't have that unless we've got photographic evidence. So we have to be able to take in information with our senses about it. If you can't take in information of the event or evidence of the event that's, sensory data, it's not science. It's not a scientific explanation. And science deals with the natural world. It has to be natural. We can't invoke anything supernatural. No Keebler elves, no invisible Jane who comes into the kitchen, turns on the tea kettle, and leaves. If Jane isn't in the kitchen, she might as well be supernatural. We can't invoke supernatural explanations. Okay. Many of you ever heard of hantavirus? H-A-N-T-A. Hantavirus? Oh yeah, it's a virus. It says right there. I couldn't remember earlier. I was racking my brain. So hantavirus is, as the name indicates, a virus. And it starts off, as many serious things do, with that vague flu-like symptoms. So, a fever, some chills, body aches, you don't feel good, and then progresses over the course of several days to the lungs filling up with fluid and a person dying by drowning in their own lungs. Whew, yuck. Particularly alarming about hantavirus is that it takes down people in their prime. So folks like you, like nice, strapping, healthy 20-year-olds, dead. Don't worry, we'll talk about the vectors. So in the early 1990s, there was a huge hantavirus outbreak in the Four Corners region of the U.S. So do you know where Four Corners is? Arizona, Colorado, New Mexico, and I think Utah? my geography of the western states, it's one of those square states. Anyway, 4 states come together. At Four Corners, there's the Diné or Navajo reservation, and there was this huge outbreak of hantavirus there. People were dying. So epidemiologists, people who study disease outbreaks and disease outbreak patterns, went to work looking at vectors and what do these people have in common and where have they been and who have they, is it transmissible human to human? How's it being spread? What they found is the white-footed mouse. So, the white-footed mouse is a reservoir for hantavirus. It doesn't affect them. The virus is shed in their urine. So, mice don't really have bladders. They just kind of run along and pee. So if you use the right kind of light, you can see their little pee trails, which if you've ever had mice in your kitchen will really gross you out and make you scrub all the counters because they leave a little trail of pee every place. Yuck. So they shed the hantavirus in their pee. When that pee dries on a surface and becomes aerosolized, like you sweep, those the little viruses are lifted up into the air. You can breathe them in and contract hanta. Okay. So they managed some cultural control mechanisms, and people were being advised that if you had mice in something, you should just dispose of it. If you had mice in that chest of blankets, you don't want to take the blankets out and shake them like this to clear the dust out. And they got it under control, and they were able to stabilize people. It wasn't like 100% fatal, but it had a pretty high mortality rate. So, scientific explanation. White-footed mouse is a vector. Virus, this little tiny thing we can't see. We can with an electron microscope, but that's a different story. Little tiny thing that's not visible to us, transmitted in their urine, particles inhaled. Okay, scientific explanation. Now, the natural and the supernatural. That is a natural, consistent, observable, traceable explanation for this outbreak. What was fascinating to many, many people at the time, and I was living in Tucson at this time, I remember reading a letter in the Tucson, it was the Arizona Daily Star, whatever the newspaper we got was, by a Navajo Diné elder who was saying the following: the reason this is happening is because people are not following the law. And by that he meant, this would be the same thing as somebody who writes into the Morning Journal saying, well, the reason we're having all these problems is because people aren't being good Christians. So he was referring to traditional beliefs held by the Navajo, by the Diné, about how the world worked. Supernatural beliefs. So what's fascinating is that within traditional Navajo or Diné teaching, mice were considered night creatures. So it's this category to which they are assigned, night creatures. And people are day creatures. And this is just like Jewish dietary law, if any of you are familiar with that. People who are Orthodox Jews do not eat pork, do not eat shellfish, have dietary laws. So these are similar among the Navajo, that, somebody who is keeping the traditional way. Mice are unclean. They are a night creature. So if you had a chest of blankets that mice got into and nested, according to very traditional Navajo teaching, you're supposed to take those and burn them. You don't wash them up and put them back on the bed. They get burned. They are unclean. They are contaminated. Because night creatures don't mix with day creatures. Now, what I find fascinating, what a lot of people commented on is, okay, you have a culture that's been living in an area for, 10, 15,000 years, who's probably encountered this virus in the past, who did not have a scientific way to understand what a virus is, or disease theory, or vectors, or anything else, but who came up with their own set of explanations about this phenomena that they had undoubtedly observed in the course of 10,000 years of living there. Was their explanation scientific? No. It totally invokes the supernatural. It invokes these mythological categories of day creatures and night creatures, and these things that are not science. But does it still on some level explain the phenomena? Is the end result the same? Yeah, it is. So can you, again with the tea kettle, can you hold two different explanations or sets of belief about something and have them both be true? Yes, you can. So I always found that fascinating. Okay, the other things that we want to keep in mind in thinking about whether or not something is a scientific explanation is that if it's a scientific explanation, it's something that allows us to predict. That is the great power of science, is predictability. We can say, well, we believe hantavirus is transmitted through mouse urine. If we take samples of dried mouse urine and we examine them, we're going to find viral agents. We can predict. And then we test that prediction by looking at mouse pee, looking for viruses. This is really the big strength of science, is we can have all these observations, we see patterns, and we can then make predictions. And it's kind of the gold standard. We have to test those predictions, though. So a prediction is useless unless you test it. And hypotheses are those working explanations. Based on those is where we make our predictions. The other big thing about science, and this is the one that for some people is hard to wrap their brain around, is that science is tentative. It is not fixed. It is not permanent. Explanations change. So, there are these rocks. These are out in Death Valley. Again, we're back in the desert southwest. There are these rocks. What do you observe about these rocks? Gesundheit. What do you observe? You guys got lots of good observations. There are trails behind the rocks. It looks like it's dry because there are cracks in the soil. We don't see any water. It's mountainous. Just rocks, nothing else. No footprints. These have been well known for hundreds of years. They were first described by Europeans who traveled through the area, probably in the 1700s, because they're pretty weird. And lots of hypotheses were proposed to explain this. How does it work? Well, maybe the wind blew them. So it appears to most people that, in fact, these are trails and that the rocks are moving in one direction. Somebody in the other class said, it looks like the trails are parallel. Yeah, it kind of does. Now, of course, that's from this, single piece of information. We could go look at, 100 such scenes, and they might not all look like that. But from what we have here, yeah, they look parallel. So, among the proposed explanations, the wind blew them. Can you test that? Yes. You can take a giant industrial fan out and hold it up to the rock. See if it moves. You can pick up one of those rocks. You can get the mass of the rock. You can do some calculations. You can think about maximum wind force. Can a wind move a rock? All that. Can't be done. What else could move these? Floods was one hypothesis. So in desert areas like this, they don't get much rain, but what they do comes pretty much all at once. So they might get less than 10 inches for the year, but that all might happen within a few hours. It's torrential. So one hypothesis was that there's a subtle slope and that the ground gets liquefied and they slide over the ground down slope. Some things aren't consistent with that, like the changes in direction that they appear to have. If they're just going downhill, they're just going to go downhill. And I actually right now cannot remember what was the leading hypothesis for years, but recently somebody actually figured it out. They caught direct observational evidence. They set up cameras on these rocks. They had their cameras up for a couple years, and they had cameras and thermometers and sensors of all sorts. And the motion sensor at one point back in the lab, the motion sensor starts to go beep, 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 beep. Oh my God, they're moving. So to the camera feed. And they interviewed a woman whose PhD, her doctoral thesis, had been done on this. She's a geologist. And she was championing what had been the leading hypothesis, and she was totally wrong. She was pretty good-natured about it. So it turns out what happens, and this was one hypothesis, but it was sort of a minority view. At night, it gets very, very cold out here. And what water there is in the atmosphere condenses. Well, the ground there is baked so hard that it doesn't absorb very well, and so you get this sheen of water, which then freezes. So you have these thin ice layers, and as they start to melt, you get liquid underneath them, and the ice moves, and the ice pushes the rocks. They think the conditions for this to happen only happen maybe once a decade. It doesn't happen very often. They just happen to catch it after only a few years of observation. But it's tentative. We used to think one thing happened. Evidence, was gathered, and that idea changed. So science changes. We've got some things that are pretty well established, but for a lot of things, we still say, the leading hypothesis is. And that means it's not settled. Something could come along and overturn the apple cart.